Hey, g'day, it's your old mate Prezzo here. I'm starting a new project today and it's all about drawbars, or specifically how to make a drawbar hammer. Now I have two milling machines and they both use drawbars that take a 17mm metric spanner. In the past, when I want to change out my tooling, which is all morse taper tooling, and I know what you're thinking, I can sort of feel the eye rolls already. What idiot would buy morse taper tooling? But the thing was, I owned a lot of morse taper tooling before I owned the milling machines, so it made sense to go with that size spindle. But to remove a morse taper spindle, you need to loosen the drawbar with a spanner, and then you need to be able to belt the end of the drawbar with a big fat hammer to get it out. And it becomes a bit tedious having to handle two tools and move those around from machine to machine. And I decided that the obvious thing to do was to make a drawbar hammer which had the socket on one end and then a copper face on the other end, so that I can knock the end of the drawbar without damaging the hex. So what I'm proposing is that I make the center body of the hammer from a piece of, I think this is 4140 grade steel. Has a chrome coating on the outside because it was once a hydraulic piston or piston rod. I've got a standard 17mm socket which is going to fit onto a square, a 1/2 inch square, and I've got a chunk of copper. The only problem is that the copper I have is square and the section is incorrect for the size of the round bar that I have. So what I'm going to try to do is to forge this piece of copper and make it shorter and bigger in cross section, and then hopefully turn it to make a matching circular face with this piece of steel. So my mission today is to see whether I can get this red hot, and I'm going to try hot forging it first, and if that works I'll just keep going with that. I can also try annealing the copper by cooling it out in water and hopefully softening enough so I can do it cold, but I probably need to repeat that heat cycle a couple of times. First step, let's see if we can get this little baby red hot, and I'm going to use my gas furnace that I use for melting aluminium, and I've got a hydraulic press that I'm going to use to try and squish this into the correct cross section. So stand by, it's going to be fun, it's going to be dangerous anyway. Well, that sort of worked. It got shorter, so I'm guessing that the material will also increase in cross section. My biggest issue is going to be trying to keep this straight, but that's a good 10mm shorter than it was, so if I just keep doing that, hopefully it gets to the right cross section. Okay, well, this is the second reheat. I think you can see what's going to happen here. Okay, well, this is the third reheat. I'm just going to try and squish it on the corners. Just try and get the correct shape. Actually, I can feel that getting thicker as it shortens. That's not bad. That's got us back close to where we should be. And just to give you some idea, that's where we were when we started. That's the full height of the blank when I started off. So we're making progress. I did hammer forge these corners a little bit flat to make it more of an octagonal shape, so I'm going to waste less copper when we start to machine this and make it circular. Okay, this is reheat number 4. Well, that's getting close. I might need 2 more, I think. Okay, it's the 5th reheat. Excuse me, I keep bumping the camera. Alright, wish I had a bigger press. So I think we're nearly half the height, and you'd assume double the cross section. So I'll see how that compares to the stock that I got for the hammer body. Okay, well here's my piece of copper stock in the 4-jaw chuck, and as you can see it's turned out a bit gnarly looking. It's sort of not really cubic, it's more of a parallelogram shape. It's sort of skewed when I was doing the forging process. So I think I'm going to get enough material out of this to make a circular face for the hammer head. It's certainly bigger than the diameter of the stock for the hammer head. Just bear in mind that this is the original stock that I started with, so I've sort of halved the height and sort of doubled the square area. The only problem was that in the original stock there was a hole drilled in here. These were going to be made into copper soldering bits, and a steel shank was meant to be drilled and tapped into the end of this copper stock. So the remnants of the hole is still there. It's sort of offset a bit now, and that could be a problem. I need to be able to drill and tap M12 to take a 12mm stud to connect that copper face to the hammer head. Of that hole is going to be a problem, but it's not very deep. It's only about 5mm deep, and by the time I finish facing this off it's going to be even shorter. So I think that's going to be okay. I've got a bit of a flat on 2 edges, but it's still a bit oversized, so I think we're going to be okay. You can see the remnants of the hole off to the side there. So I'm going to drill this about 8mm, and then I'll open it out to 10.2, which is my tapping size. Yeah, well, I should have seen that coming. It's the drill bit ran into the off-center hole, and so now my hole is eccentric. So I'm going to need to bore that out to my tapping size. So I've got a little tiny boring bar. I'll try and get in there and clean that hole out. Well, just at the critical moment my camera battery died, but what I've done is I got this little tiny boring bar and I've bored the hole out to 10.2 millimeters diameter, and then I counterbored to get rid of the remnants of the eccentric hole, and that'll give me a chance of getting an M12 tap started in that hole and getting it to thread concentrically. Okay, slight change in plans. My M12 taps, I didn't have a bottom tap for an M12, so I'm going to go for a 1/2 inch BSW instead. So just see how far we can get in with this taper tap. Not very far, I'm guessing. Okay, well that turned out to be a lot harder than I thought. Okay, well I got a 1/2 inch stud in there and just cleaned off that end. If you're wondering why I cut it with a hacksaw, I just didn't trust my parting tool. I don't know what quality of steel this is. It tends to bind up on the parting tool. The last thing I want to do is bend all that and mess up the thread. So we'll wind this piece of copper on now and get that tight on there, and then I can finish turning the outside diameter and the face. I got a few little imperfections there, which is disappointing, and I don't think I'm going to clean them all up. case of close but no cigar. I've got a little flat spot there, another one here. I'm not quite down to size yet. So I'm going to bring this down exactly the same size as this stock here, and maybe just, I don't know, put a very slight taper on it if there's still some evidence of that little defect there. Alright, let's get rid of the defect. Okay, I'm pretty happy with that. I don't want to go too over the top with the finish on this. It's going to get all scarred up the first time I use it anyway. Well, there's the finished square on the end of the hammer head. So you can also see that the copper head's been permanently attached now to the steel hammer head. I just simply screwed that on as tight as I could with a wrench before I finished doing the taper. So I don't think that's ever going to come off. In the end of the square, I've got a 5mm threaded hole, and the socket is just simply going to fit over that square. And I've made a washer, purpose-made washer with a tapered flange, and that's going to be held in place with a 5mm socket head screw. I didn't want to rely on a ball detent to hold all this together, because in operation I'm going to be sort of belting the end of the drawbar, and I sort of felt like the socket would want to work its way loose. So with that socket head screw holding everything in place, I don't think that socket's going to come off at all. The handle of the hammer is going to be held in place with a piece of 10mm all thread, and the aluminium part that I've already made up just fits into the counterboard socket on the underside of the hammer head. Now, I'm sure that a lot of you looked at the setup I used to cut that square and probably nodding your head and saying, this guy doesn't know what he's doing. He should have used a square collet block. Well, yes, I have one, but even the biggest ER40 collet that I had is not going to take that size stock. I do have I've actually got 3 dividing heads, but the chucks wouldn't grip the steel part. I could only have enough depth in the jaws to grip the tapered coppered section, so none of those setups going to work. And I messed around for a long time and eventually decided I was just going to index the part round manually, and for what I was doing it worked fine. Yes, there are more elegant setups and certainly more accurate setups, and if it was a situation where you needed that square to be absolutely concentric and absolutely square and spot on for size, I would have done it some other way. But given that all we're doing is just sort of resisting the twisting motion or the torque, I think what I've got is fine. So in the next video, I'm going to cut this video off here and just stick with the metalworking part in this video. In the next one, we're going to make the handle for the hammer. And I do it in a way it's just decorative, basically. I could just make a cylindrical handle out of wood, clamp it in place, put a nut on the end of the all thread here, and it would work fine. What I'm going to do instead is I've got a whole bunch of scrap material, all different types of timber. This is Queensland maple, this is a bit of New Guinea rosewood, that's a bit of Tasmanian oak, and that's Tasmanian blackwood. Or Tasmanian myrtle, sorry. So I'm going to use all of this stock and I'm going to make a laminated timber handle. And the setup I'll be using is going to be done by clamping all of these small pieces together using this all thread and a nut. I'll laminate it all up with epoxy resin glue, and I'm going to attempt to CNC mill the handle so I can get that sort of elegant profile that you see on most hammer handles. So tune in for that. It should be fun. I think it's certainly going to be different and interesting. So for the moment, we've got the business end of the hammer done, and I love this piece of copper. It's just going to be heartbreaking the first time I belt it on a drawbar and mar it all up and damage it, but hey, what can you do? So for now, thanks for watching.